entire time. A new UEFI flaw enables pre-boot attacks on motherboards from Gigabyte, MSI, Asus, and ASRock. Guys, a very interesting vulnerability today in the world of DMA, right? Direct memory access, and how this affects this particular line of motherboard manufacturers. So in the world of motherboards, you have this thing called DMA, right? If you have a device that does very fast data transfer, think your network interface card, or more particularly your GPU, your graphical processing unit, these things have to be able to send data at gigabits per second to your computer directly with as little input-output overhead as possible. So this world of DMA, which allows the device to write directly to a location in memory, enables that to happen. In computer hardware, we kind of have these two paths for when data is going to leave the CPU, right? If we want to make the data leave the CPU and go to RAM, that process goes through the MMU, the Memory Management Unit. It takes the thing that is a virtual address, the address that the process thinks it has access to, and it translates that down to where exactly in RAM that lives. It goes from virtual to physical. It gives the CPU the impression that it has access to all of the memory, when in reality it only has access to some of the memory. This same process applies to the world of memory mapped I/O when you're talking to an input-output device, and this is where DMA occurs. When you want to talk to your graphics card, right, before you can do any of that, you have to set up a special set of pages in the I/O MMU, so that when you write to the virtual address, FFFF1200, when you write to this location, it actually punches a hole through the I/O MMU and writes that packet out onto the PCI bus so the graphics card can get it and render it. This whole world of DMA is what enables really fast translations to happen and really fast transactions for high throughput data. Before we go, guys, look at this. This is 984747. It's almost 1000000. It's almost a million. If you could hit subscribe, I'd really appreciate it. It'd be great before the end of the year if I got a million. That'd be neat. That'd be really cool. Okay, let's keep going. So why is this a problem? Well, actually, the people that found this vulnerability are the researchers at Riot. They make the Vanguard anti-cheat, and they said that Valorant currently will not load on vulnerable systems. Why is this? How could this system of direct memory access be a problem? The vulnerability causes the UEFI firmware to show that DMA protection is enabled even if the I/O MMU did not initialize correctly, leaving the system exposed to attacks. So how could you attack anybody with this interface? Right? Well, in this scenario, we have a very benign, a very cooperative device, right? We have the NVIDIA GTX, whatever, 5070, right? Maybe GTX is incorrect, but you know what I mean. I'm not a hardware guy. Okay, relax. 5070 here. But what if, for example, I plugged in really, really evil interface card? The card, right? And literally all this thing does is it sits in the PCI bus, right? If there is a misconfiguration in the I/O MMU, it may be possible that this device over DMA, by sending a write request, can overwrite data that lives inside the CPU. Basically, this vulnerability is that by default, when the I/O MMU comes up, it should have DMA pre-boot protection enabled. What you don't want to have happen is a PCI card to be inside the computer and be able to transmit write requests to overwrite a region of the memory that has maybe the operating system, right? Because the whole point of secure boot, for example, is to go from the UEFI root of trust, so we have the UEFI certificate authority here. It does some variety of signing. It signs maybe a shim in the Linux scenario, and eventually it loads the OS that is signed by the upper level shim, right? What you're doing in this is as the PC boots on from UEFI and is less trusted, you are making it more and more trusted to eventually load the Windows or Linux operating system, right? So secure boot at this time means that, yay, the OS is signed, it's good, we have a little check mark there, right? We know the OS can be trusted, right? We do a little check, it's a V. It's good to go. But after the secure boot has occurred, if the I/O MMU is not properly established, there is a world where we can then use this to overwrite locations in the OS and do evil stuff. And in the case of Vanguard, they're very concerned, obviously, with cheaters, right? The whole world of DMA attacks and cheating is hard to defend against because they have to be aware of all DMA attacks that can occur that won't necessarily show up as like a process or a kernel module, right? DMA attacks are hard to detect because there is no transaction that occurs that gets mediated through the kernel. Once the page tables are established and able to be written to by the DMA card, unless you can detect the DMA card on the PCI bus, you're not gonna see it doing its thing. It's very hard to detect. Now, Vanguard, or Valorant rather, what is it called? Vanguard? Now, Vanguard does load as a boot stage loader, which means basically it loads in before the rest of all the other drivers. So it has very, very early hooks put in. But that being said, it still is extremely hard to detect these. So because of this, they depend on pre-boot DMA protection that tells basically the computer, hey, the IOMMU is not allowed to let any transactions come through that could do anything evil. Well, again, the vulnerability here, the attack requires physical access for malicious PCI devices need to be connected for a DMA attack before the OS starts. During that time, the rogue device may read or modify the RAM freely. So what is the bug? Even though the firmware asserts that DMA protections are active, meaning the IOMMU is configured and blocking, it fails to properly configure and enable the IOMMU during the early handoff phase in the boot sequence. This gap allows a malicious DMA capability PCI device with physical access to read or modify system memory before operating system level safeguards are established. That's not great. So what this literally means, guys, is the IOMMU, like the UEFI, or the motherboard firmware is like, hey guys, listen, we got it all set up. It's ready to roll. The CPU is hardened. All those PCI attacks are coming in. We're not letting them in. But he's like, yep, guys, just back, beep, just back him up. It's no bueno. Okay. Now again, how this happens at such a scale, again, it'd be one thing if like one manufacturer did it, like, oh, they made a mistake, but it's 4 manufacturers. I think I read somewhere this is like a misunderstanding within the UEFI spec on like who is responsible in the boot process for hardening the IOMMU. Kind of crazy. And so yeah, as a result, if you have these motherboards, like again, this only matters if you are under the threat model where like someone's gonna walk into your house and put in a wacky PCI card, or like maybe you want to just like hack and you want to play Vanguard, or you want to play Valorant with like cheats. I don't know, either one of those. But yeah, these motherboard manufacturers are affected. Now there is a caveat here. It doesn't necessarily mean that it can read and write the RAM freely. It's basically going to be a function of the default configuration of the IOMMU, right? At the end of the day, all the IOMMU is doing is receiving requests off the South Bridge on the PCI bus, and it reads the headers of these requests, right? These things are called PCI TLPs, translation layer packets. Inside the TLP, it's going to have a destination address that it wants to write that data to, and that destination address is going to be some virtual memory address, right? It's going to be a device address so that the PCI device doesn't like get exposed the virtual memory map of the kernel, right? The IOMMU is going to give it a fake address that it's going to use to map into another memory range. So the destination address may be this, right? You know, a bunch of F's and some zeros, okay? Now, when this thing hits the IOMMU, all the IOMMU is going to do is look inside its table of addresses, comma RID, the device identifier, right? Because this is going to be a function of not only the virtual address space that it's given, but also the device name that's on the PCI bus. And it's going to look and see, okay, cool. Do I have an entry with these two as keys that maps out to some virtual kernel address, right? Or some memory address I want to write to. And so maybe there's like, you know, I don't know, F7001234 is the address, right? Obviously, it wouldn't be this, it'd be page line, but that's not the case. Or not important right now. And then it uses this to then take the data and it gets written there, and like that is the translation that occurs. So to say that like it would be that a device could access any memory address would be a function of what translations exist in the IOMMU by default when the device turns on. Now, I'm really, and again, I didn't do the research, so I could be wrong. I'm really hoping that the default answer is not like, oh, the device turns on and then IOVA, the IO virtual address space, just maps to the entire RAM space. That would be crazy. That would be the worst security by default I've ever seen in my entire life, right? But as far as I understand it, you have a PCI TLP that hits the IOMMU, does a translation, and it writes it somewhere. So if this page table translation does not exist, it can't do the write. And so luckily the researchers at Riot at Vanguard, you know, they found this vulnerability in all these motherboards and they reported them to the manufacturers, and they are currently in the process of fixing it. And what is the solution? Well, they just need to update the firmware on the boards to make sure that like the IOMMU is properly configured as early as possible so that, you know, there's no device that can sit in there and do something evil before the IOMMU comes up, right? Because like it either should be completely turned off and processing no translations, or only processing translations of the OS. If it's in some weird, like half open, misconfigured state, then yeah, the IOMMU is like not doing its job at all. You don't get any pre-boot DNA protection, which is just crazy. Yeah, and so what can you do in that window? You're able to use that to have hardware cheeks that sneak in, inject code, and hide themselves before Vanguard even wakes up, where Vanguard, again, is a boot stage driver that loads before everything else. So just crazy. And would Rust have fixed this, guys? No, guys, who are you talking to? Obviously not. Obviously not. Anyway, guys, if you like this stuff, do me a favor, hit that like button, hit subscribe. Go subscribe. I'm almost at 1 million subscribers. That's crazy. Go check that out. Go press the sub button, and we'll see you in the next one. Take care. Goodbye.
As a society, we've become used to computer problems of one kind or another, just as we've become used to computers. We're so used to them, in fact, that few of us stop to think of the extent to which they now play a role in our everyday lives, a role that shows every sign of growing even bigger.
If you look at sort of the process of the technological revolution that we're all in, it's a process of taking very centralized things and making them very democratic, if you will, very individualized, making them affordable by individuals for a small collection of tasks, if you will, sort of from the passenger train to the Volkswagen.
I mean, you think back just a couple hundred years and people could barely even travel between states, let alone get information from one place to another instantaneously. That is power. That is so powerful, having instantaneous information transfer. That's the biggest breakthrough of all of it.
Back in the day, you used to have to know how to code or at least how to speak a programming language to interact with the computer. Nowadays, all you have to do is swipe right. So the purpose of this video is to lay a good foundation to step by step understand really what's going on inside a computer. And I mean, like, physically, we're going to demystify
well, like, how is that possible? But it's true. I mean, just look at the
Seed Studio. Watcher. What you're talking about? Watcher? I hardly know how to tell the time. Oh, what the hell is this? Upcycling device packaging into a stand. Hold on a sec. Hold on a sec. USB-C cable. This is a big one. What is it? I'm gonna plug it in.
Enter the Wi-Fi configuration mode.
Did you hear that? It wants my Wi-Fi. SenseCap Watcher, the world's first physical AI agent for smarter spaces. Work with OpenAI. There's not a chance. Hold the wheel button and then it will take a while to boot up. Right, I have connected it to my Wi-Fi.
Please log into the control panel to add the device. Enter the verification code. 5, 4.
Apparently. I feel like mine has like developer firmware or something on it. This is nothing I'm seeing looks like what we've got here.
Please log in.
4, 3, 2, 1. I'm going to flash the firmware to it in hopes that that makes it do something.
Please log into the control panel.
I know, I'm working on it. Wow, this seems extremely easy to screw up. I have to put in like the memory offsets for where things need to get flashed. Okay, the files.
Please log into the control.
I'm working on it, dude. I have no COM port. Hold on. There's 2 USB ports on this thing. Aha. We will try COM 4. Go. Okay, it just says sync. Worried there. This thing is a little beyond me. While we wait for that, we'll, let's check on the battery. Okay, so this car charger has been charging. Not a car, but itself. Still says, can I interact with the instructor or other students during the course? Okay, I guess we're using the paper one. Do I have to connect it to a tire first? I've connected it to a tire. It seems to work. Okay, well, to test this thing it was what, $80? $80. It feels kind of cheap. It's a thoughtful gift, because if someone got it for you, they would not want you to be. She's dead. All he wanted me to do was insert the code on the control panel, and I ended his life for it. I'm gonna flash it one more time. Okay, well, you are hereby disqualified because I annihilated your innards. On to the next thing, big boy.